HR Bakery presents LDR6023C development board. This is a customized development board that I built. This board is going to be used in a digital analog converter. This board allows you to play music while charging simultaneously. It also supports flash drives while charging, as well as other OTG devices. Now, before I tell you how this works, you need to understand the 3 USB roles. What are the 3 USB-C roles? Pause the video and think about it. What are the 3 roles? The 3 roles are charge, data sync, and USB host mode, aka OTG. Now, some Androids don't support OTG while charging. The Samsung S21 Ultra supports OTG while charging. Here's how. Now, a few things I changed. 4 of these resistors are normally supposed to be 100K, but as you see right there, based on the numbers, as you can clearly see, I made them 20K so it switches faster, because otherwise you gotta wait like 6 seconds before this signals chargeable music. I only have to wait like 3 seconds or less for this one to signal, because I used lower values of resistors near the transistors over here, the MOSFETs. Just keep in mind you have to use expensive MOSFETs if you make the resistor values lower, otherwise the MOSFETs will overheat. So I swapped the MOSFETs after swapping the resistors, and the overheating issue was gone. Now keep in mind, this USB chip still gets a little warm. You're going to have to put a heatsink under the whole board if you use this hours on end. But anyways, let's explain how it works. So first the 12 volts comes in through this adapter. Then this USB-C chip converts it into an interface. It's the exact same thing that's found in this power adapter, just the USB communication chip, not just the USB PD controller, not the rest of the components, because the rest of this is just a power supply. So just this chip converts it into a USB-C, and the phone negotiates what voltage it'll output. But the thing is this chip uses 5 volts regardless of what voltage your phone charges at. So the way you have the 2 voltages that are needed is this chip converts this 9 volts coming out of there into a 5 volts. There's a resistor soldered here to limit the power to 18-watt charging, because I never like to charge my phone too fast. I find if I charge my phone too fast, even without the music, what'll happen is the battery will die much quicker, even if it gets to 100%. So I find the sweet spot for fast charging the Androids is 18 watts, so I soldered a resistor here. In a future design, I will build one without the resistor, and it'll be a special design that supports tablets as well, where you could charge and take advantage of the full 60-watt output this thing could output. I decided I didn't want a USB-C port here, so this XPM52C chip converts it into a USB-C, and these other components are just required for this chip over here, these components around here. Then it goes through this chip, which is the HUSB332D. Now, because this is recreating what's in a phone charger and cables are really long, these components don't need to be very close to this chip. It was more important to get these components closer to this chip as far as I knew. So basically you have to recreate everything that's found in a USB-C cable along with the phone charger. So I recreated that using these 2 chips here, XPM52C and the HUSB332D. That powers this buck converter chip, this NDP chip, and this gives the 5 volts that this thing needs. Now I've also decided, now let's say your phone charges at 9 volts, how does this get 5 volts? Well, this converts it to 5 volts, but before this chip, this bypasses this chip, goes straight to the phone, and your phone will communicate with this chip and it'll negotiate the charging voltage, so the phone gets what it wants. And these transistors switch between the 2 roles, music and charge, or OTG and charge. So I don't know exactly how this works. Unfortunately, I can't provide the original reference design as that is confidential, but you can contact Legendary yourself and get the reference design from them, and they'll give it to you. I modified it to my liking. I could probably share my reference design because my design is different from theirs, the way I changed it. Anyways, without any further ado, let me show you how good the performance of this board is. And I used expensive transistors for even better performance. So you see I got my phone right here. Now let's plug it in. USB Type-C connector. This is a homemade USB-C cable with silver-plated copper wire for better sound quality, but I will show you this works on any USB-C cable. You don't have to use the one I built. And as you see, it's charging. And it's coming out of the speaker. I could adjust the volume. I'm going to keep it low because there's someone upstairs I don't want to disturb. No copyright music, so I don't got to worry about any problems. But yeah, as you see, LDR6023C, customized module I built. It lets me play music while charging. Now, normally in a finished design, the DAC would connect via this thing here. But I've decided that I'm just going to use this port and solder a bypass red wire. But the reason this isn't soldered directly onto this is because sometimes a switch could go between the two depending on how you want to wire this thing. But another reason I put this USB-A port was really meant for older devices, and it basically bypasses this whole thing here. This port doesn't support music while charged, but this port does support music while charged. So this port will really be used for flash drive outputs, while the DAC will connect over here. Of course, flash drive or DAC, you have to pick one device. You can't have two of them plugged in simultaneously. But you could have audio and charge simultaneously, as you see. Now, if I pause it, unplug this, reversibility, as you can see, that is not a problem at all. Reversibility works flawlessly. Sometimes it has to switch though. See, it works just fine, reversibility. If my connections weren't so flimsy, it would work a little smoother, but... And again, the volume control works just fine. So yeah, I successfully built the circuit that lets you play music while charging. Works great. Now, if you wonder why this crude setup, it's because my terminal wasn't big enough to fit these things in. Yeah, my terminal wasn't big enough to fit these things in. But you get the idea. This circuit lets you play music while charging. This is going to be used in the digital analog converter power bank. I need more parts before I can build the final project. I ordered a headphone amplifier for even better sound quality because the sound quality of this just isn't good enough for me, so I ordered a headphone amplifier module. I know I could build a much better DAC myself and build a better headphone amp myself. There's schematics you could copy online that were tested by audio engineers. But I decided to play it safe and just use this DAC I already have and just buy a headphone amp module and play it safe because I don't have an electrical engineering education. Like, all I did was modify the schematic a little because I'm very good at wiring things. So, yeah, please don't forget to like, share, and subscribe. And in the next video, or in an upcoming video, I don't know if it'll be the very next one, in an upcoming video, I will show you this board used in a digital analog converter. This will be built into a digital analog converter, so you won't have all these bulky wires everywhere. This is just a demo test. So yeah, hope you enjoyed the video.